Let's work problem 16-36. Rod presses against AB. So this is pushing here, and rod DC is moving that direction. If the angular velocity of AB, this one, rotation here, is maintained at 5 radians per second, determine the required magnitude of velocity. So if this is rotating at 5 radians per second, what is the velocity as a function of theta? So we want to look at the geometry because this is absolute motion analysis. So first we want to draw the geometry. So if we look at that triangle here, this bottom side is x and this is 2, and then the angle is theta. So off of that we can write the equation: the tangent of theta is equal to 2 over x. I'm going to rewrite that with the negative exponent, since the next thing we're going to do is take the derivative. So the derivative of tangent is secant squared. And the derivative of 2x to the negative 1, secant squared, is the derivative of tangent, but then the derivative using the chain rule of theta is theta squared. So the derivative of 2x would be negative, bring down the negative 1, negative 2x to the negative 2, and then chain rule, the derivative of x is x dot. Okay. Now, this x dot is the velocity of x. So this is x. So x dot is how fast x is changing. Well, x is changing at the rate that this point is moving to the right. So that point is moving to the right at the rate v. So x dot is equal to the v we're looking at. And theta dot is the rate of change of this theta, which is also omega. So theta dot is equal to omega, which is equal to 5 radians per second. So putting v and omega, or 5, into this equation, we have the secant squared of theta times 5 is equal to negative 2 x to the negative 2 times v. Okay, so there is our derivative. We could redo this with a positive exponent there, and we get secant squared of theta, 5 out front, equals negative 2v over x squared. They want v as a function of theta, so let's rearrange with v on one side. So v, x up there, divided by negative 2, so negative 2.5 x squared secant squared of theta. We don't want x, we want it to be as a function of theta. So looking back at our triangle here, we can write that the tangent of theta is equal to 2 over x. So x is equal to 2 over the tangent of theta. Putting that into there, we get v is equal to negative 2.5 2 over tangent theta squared secant squared of theta. So there we have it as a function of theta. That's not real pretty. Let's see if we can clean that up a little bit by using the sine and cosines instead of tangent and secant. So the velocity is equal to negative 2.5 times 4. Let's do that. 2 squared is 4. 4 times 2.5 is 10. Tangent, 1 over tangent. Tangent is sine over cosine. Flip it upside down. Cosine of theta over sine of theta squared. Secant is 1 over cosine squared of theta. That cancels with that, and the solution is negative 10 over sine squared of theta, which becomes cosecant squared of theta.